بسم الله 1 2 3. One, two, 3, 4, 5, 6, 7, 8, 9, 10. One, two. هذيك كانت شاشة ثانية ال LCD. اي هذا موجود. نعليها. لا مو اللابتوب، كانت أول شاشات. كنتوا موجودين أول يوم. اي كانت شاشات دحين. يس هذه دحين البروجيكتور. One, two, 3, 4.
1 2 بسم الله 1 2 3
لا هذا أكثر حاجة. بعدين بس. مؤتمر. بس أخلص اللي في يدي وأجيك على طول. اي الشاشة دي، انا اجيب لك عمال يشيلوها. تبي تطلعيها بالكامل من القاعة ولا تبي نحطها على جنب؟ اوكي. اوكي تمام تمام. اوكي تمام لا تشيلي هم. هي ايوه هي نفسها. ايوه. فشو اسمه، هتحتاج واي فاي. كيف؟ ايه ايه، ما عنده. هي في قاعة كم؟ 207، حمام نواني. انا قلت له احنا مشغولين في المؤتمر بس تبغاه مؤقت، تبغاه دائم يعني عشان عندك لا. كيف حالك استاذ غدير؟ طيبة. الحمد لله. ايوه موجود كل عندهم هنا كلها كاملة، لازم تجي. مو موجودة.
You just
اه
in case someone didn't show up.
اعتقد رسلوا لي اجندة.
بالضبط.
بس دكتور عبد الله اوكي تمام.
See? تالي دكتور نبيل ما حنحتاج حاجة.
هذا البرزنتيشن دكتور عبد الله، هذا اعتقد حق مين؟
شفت اسمه بس
ايوه. أوكي. ما تحتاجه ها؟ اوكي. أمم. هذا حقه اوكي. بس الدكتور يحتاج يبي يشغل لابتوب ثاني بيخليه جنبه عشان بيشوف.
جيب اللابتوب.
ها؟
شوف اللابتوب.
هو اوريدي عنده لابتوب.
طيب عشان اللابتوب ويهاجم.
تمام؟ ايه خلاص يقدر يحط لابتوبه هناك.
خليه يجيب في النص.
ها؟
هيشتغل ايش؟
بس يبي يشوف ما يبغى يشوف. مثلا هنا حيكون عندك الجبريل، حيكون زي سكيل ولا حاجة بيقرا من جهتين، ما يبغى يبين الناس هو يشوف. كيف يعني؟ أول
Huh?
Assalamu alaikum. Hello. Assalamu alaikum. Now we have talks from our keynote speakers. We have two keynote speakers here. Our first keynote speaker is Dr. Abdullah Al-Sohebi. Let me give a brief about Dr. Abdullah first. Dr. Abdullah is the founder and CEO of International Enabling Training and Consultant, past chair of IEEE Communications Society Saudi chapter. He is also IEEE SOC International Affairs co-founder, board chair for Innovation and Technology Association, co-founder for IoT in KSA Association. The topic of his talk will be From Connectivity to Intelligence, 5G, Open RAN, and AI for Smarter Cities. I welcome Dr. Abdullah.
Presentation. Okay. Okay, عندك البوينتر. تمام تفضل.
Thank you, Doctor, for the introduction. Assalamu alaikum, everyone. Today's session, I prepared it to be semi-technical, but since most audience here are students, I will try to go in different levels. Okay, zoom in and zoom out. And if you allow me to take after the 15 minutes, because today we have only two speakers, if we can increase the time 5 minutes for questions on the students. If you give me the green light, I'll do it. If not, I will stick to the original. That should be fine. Okay, we'll do that. Okay. Okay. We will be discussing today different than what we have discussed yesterday. Yesterday was about the use cases and the value creation. But today will be mostly about the infrastructure. How do we do these use cases? How to enable these use cases? Okay, so we will be going through different different topics here. AI, what is AI, and how we make AI as a value creation for telecom infrastructure. Okay, then OpenAI. Anyone have heard about OpenAI? Open RAN. Not Open RAN. OpenAI is famous, but Open RAN is similar to OpenAI, but in the infrastructure side where we do radio access network as an open interface for innovation. Okay. So let's recap what is AI. AI, it has three models mostly. One is the supervised learning, then unsupervised learning, and the reinforcement learning. Okay, each of those have different use cases. Most of the use cases is image recognition, which you use mainly on a daily basis for face recognition. That's an AI type of form of one of the AI use cases. Natural language processing is also AI use case. And finally, robotics, which is the most advanced use cases for AI. All right. Sorry, I'm confused here. Okay. Now let's delve into the infrastructure. Mobile network, cellular network, okay? In cellular network, we have many features. MIMO, for example, massive input, massive output. If you remember back in 2017, the Kingdom have announced going from 120 megabits per second for users up to 180 megabits per second per user. So if you if I want to translate it as a user, if you hit speed test in your mobile, okay, back in 2018, it was around 10 to 12 megabits per second. If you hit it now, not less than 500, because 5G is enabled here in this college. There are a cellular tower outside just to give you a boost on the throughput, okay? Now, where are the use cases for AI in telecom infrastructure? We have smart network planning and design. In the planning and design, we use AI for neighboring cells. Neighboring cells, I mean by that, one tower see another tower. For example, in Jawhara, there are 5 or 6, at least, different towers. Here next to the college, there are one tower. There will be overlap of signals, which affect the user, okay? If manual input has been inputted into the network as a planning and design for those towers, there will be some margin error there. But AI resolved that and reduced the error by 10 to 15% of error. So this is an increased efficiency. All right. We have NOC and SOC, Network Operation Center, and Security Operation Centers as well. AI dedicated there, and it was introduced back for the first time. It was introduced back in 2021. I think it was STC, the first operator to use AI in Network Operation Center, and Security Operation Center was STC, and they transformed their network based on that. Not only that, but they subsidized one of their companies, Sirar. Have you heard about Sirar? What does Sirar do? They are taking care of the security, only cybersecurity. It's a whole company for cybersecurity of the infrastructure for STC. That's what they do. Okay, and it's a whole company. NOC, now they are subsidizing that STC as well to have a Network Operation Center as a company on its own. Okay, IoT Squared, for example, this is one of the use cases companies for STC as well. And the value creation is emerging. From now up to 2023, there will be some more companies we use AI in there. as a main use case and as a main value creation, right? Field operation and productivity in the field. Okay, I will not go into that because it's a complex topic, but we use it on the field as well for drive testing, cars going around neighborhoods to measure the signal and the quality of the signal. Okay, energy efficiency, network performance, which is your speed that you see. We see it on the network operation center as well, and we fine tune it to maximize the throughput for you. When I say throughput, I mean speed. Quality of experience optimization as well. All right. So moving on to the standardization in the 5G, starting from 5G 2020. There were some minor uses of AI, but as 5G advanced came into standardization and was standardized and published back in 2024, there are many use cases of AI there. Okay, some of them I just mentioned on the network operation center, planning and design, network planning and design, network performance. Some of them in the air interface, the interaction between you and the tower, the cellular tower. There are signaling, what we call it signaling, just to control the user energy and also the power of the signal, the mobility. Actually, it's going on now on each device you are holding. I see some of the colleagues here touching their phones. This is an intensive use of signaling, okay? They are using power. If there are no AI there, there will be some major waste of energy, which is costly, okay? And this cost, by the way, it's translated to you, and it will be paid by you, all right? In the 6G, which is coming 2027, 2028, sometime in 2028, there will be a native AI infrastructure, okay? It's merely expansion of what we have mentioned on the previous slide. All right. Now let's touch that and translate the infrastructure to use cases in smart cities. All right. If we look at smart cities, what are they? It's communication everywhere. Okay, connectivity. If there is no connectivity, there is no smart cities. All right. So smart cities, actually, it's talking about connectivity. IoT is a device, right? Connected to the internet. How? Mostly by wireless communication, either Wi-Fi or narrowband IoT. Narrowband IoT, one of the cellular network use cases. It's narrowband, uses low energy, okay, to maximize your battery device. The battery device level, okay? The consumption of the battery device. Okay. If you are using 5G, it will be draining the battery more, right? In the standard point of view, there are some levels of domains, okay? There are 3 main domains on the experience side, which touches the users. In the extension side, which is the radio access network, which is between the user and the operator, which are the towers that you see distributed everywhere, including some of the towers I see it on the roof here. There are some indoor, we call it indoor solutions. Okay? Wi-Fi routers are still access point, right? And then in the network itself, as an expansion of the network operation center, for example, to be optimized and to be expanded, performance management, okay? Orchestration, network orchestration, which are in there. Network energy saving as well. One of the actually LEAP 2025, which launched yesterday in Riyadh. And I advise you, by the way, to visit LEAP if you have a chance this year or probably next year. It's going on for 4 days every year, every February. It started yesterday, today, and it will be finishing after tomorrow, inshallah. Okay. The main title or the main theme of the LEAP this year is AI. Okay, AI everywhere. In the network operation and network design, network planning, it's everywhere. Okay, from the air interface. I see that you are getting bored. For students mainly. No questions so far. Let's just allow me, please, to have some interaction between me and the students. No questions so far. You understand what I'm saying? All right. Now let's move on from this slide. The main takeaway for this slide is AI everywhere in the infrastructure side. Okay. Since AI is everywhere, that's a touch point, and that's an interest for any engineer, either in the computer science, IT, security, cybersecurity, anywhere. They can work on the telecom field. All right. So if we look at any telecom infrastructure, cellular network mainly, okay, from 60 to 70% of the budget that any operator spend, it's actually on the radio access network. The backhaul and the core network is 30% only, okay? So the radio access network is budget hungry. Why? Because it's distributed everywhere. How many towers, by the way, you think STC only has in the kingdom? How many access points for mobile network? What do you think? Any number? Millions. Oh, that's too much. No, I mean outdoor, only outdoor, no indoor. Up to December 2024, 1 month ago, 21,000 access points. That is the tower of the 30-meter high towers. Okay. Taking away from that Corniche, which is 15 meters high towers, that's not counted, by the way. All three operators, including Mobile and Zain, they have 52 or 55,000 towers. Thinking about this distribution and this large number to coordinate between these network nodes, it's so complex, right? And this is why AI is mainly used there and getting evolved even standard by standard. And the more standards coming up, the more advanced AI getting in those use cases, all right? But what are the domains of the AI in the radio access network? We talk about planning and design, deployment, optimize, and operation and maintenance. On the operation and maintenance, we have something called network slicing orchestration. Okay, you heard about network slicing. Network slicing, actually, it was launched yesterday as launched last year as a pilot for STC and Mobile. This year, Zain will launch network slicing. But what is network slicing exactly? It's to slice the network with different quality of services, okay? Depends on your subscription, you will get certain quality of services for you as a consumer and also for other use cases like IoT, smart cities, applications, and so on and so forth, okay? This orchestration between these slices is so complex in the backhaul, okay? And in the core network as well. But this is why they use AI for orchestrating the network and network slicing mainly, let alone MIMO, massive MIMO, beamforming, other features, all right, which are more complex even than orchestration. Moving on, Open RAN, I mentioned that at the beginning. Open RAN, this is a new concept that driven by operators around the world. This is a global movement between operators. They came together, although they are competitors, but they saw the need for opening the radio access network. Radio access network dominated by only 3 vendors, mainly Huawei, Nokia, and Ericsson. All right. In Jeddah, I think Ericsson, what you see in the streets, mostly Ericsson, operated by Ericsson, deployed by Ericssons. So if you look at the tower itself, you will see Ericsson logo in the equipment. All right. Mecca, Medina, for and Masha'ir, it's Nokia, and the rest of the kingdom, I think Huawei. So what is Open RAN? Open RAN is opening the front end of the network, the signaling between you and the tower to be open. Why they need it to be open? To open up new use cases, new innovation. Because nowadays, 3 vendors, they are not enough to create new values, okay? They are mature enough and they get their cake of the market and they sit on it. They don't innovate enough, right? Let alone the pricing and other things. So the aim of Open RAN is to open up the front end, integrate intelligence everywhere in the network, interoperability between different vendors, right? And virtualizing the network at large. Okay. Virtualizing the network, this means that the equipment you see in the cellular network is not anymore dedicated for cellular network. You can take it off, use it somewhere else for another use cases, which they use it as they call it off-the-shelf equipment, right? So moving on between the traditional cellular network, radio access network, I'm talking here about the towers that you interact with, okay? What it used to be as a legacy network, it's non-virtualized, dedicated set of equipment. Whenever it's outdated, they throw it on the bin. They don't reuse it. So this is a big waste of CapEx, all right? Then they used they moved to centralized RAN, where they moved some of the equipment to a central location. This central location serves multiple access points, all right? Then virtualized RAN, which is going on now in Masha'ir specifically. We are doing this task now for Mina, Muzdalifah, and Arafat. And then the next stage is to move to intelligent Open RAN, okay? But this point will take some time, the last one, all right? This is to give you some history of the movement. Yesterday, I think either Dr. Mona or Dr. Samer mentioned that 3G is not there anymore. You know, in the kingdom, there are just 2,000 or 3,000 sites operate 3G. They are shutting down 3G. In 2027, there will be 0 3G in the kingdom. This is not only Saudi Arabia, it's a global movement. Why? Because it's technology behind it. WCDMA, what they call WCDM, it's so complex, right? Costly, and not even adding more value to you. So they moved to 4G advanced, they switch it to 4G advanced and 5G advanced as well. All right, moving on, I think I'm taking some time. Who are driving the Open RAN? As I said, some of the operator, STC, one of them, BT, AT&T, US Cellular. These are the founder members of Open RAN. And also the AI RAN. This is a new initiative by industry to use AI on the radio access network for orchestration and signaling. There are some founders of those, Nokia is one of them, NVIDIA, and ARM, so on and so forth, right? Moving on that, I think we need, I'm done with the slides, but we need some 5 more minutes if you allow me. Are we up with the time? I didn't look at that. Okay, 5 minutes for questions. I think you have questions, right? If you don't, I will ask. Go ahead. Is there any mic that we can, or you can raise your voice? Open eye, open RAN. Very good question. You will have more speed, let's say. Throughput will be increased for you as a user. Why? Because I'm dedicating some slides to other use cases. Now, in the traditional way, without network slicing, you are congesting the network. How much Snapchat you use every day? Snapchat is a data-hungry application, okay? YouTube, right? You are congesting the network. Now, if we have Open RAN, then we will be dedicating easily to you as you open up social media, switching the quality of services quickly so that we increase the throughput for you, decrease it to someone else who doesn't need it, all right? This is simply how it does. But nowadays, on the traditional way, it's not the case. This is why sometimes you have 5G logo, but still out of service. All right, buffering, circle of death, as they say. Any other question? Did I answer your question, right? Go ahead.
All that radio signals are not good for as far as the ecosystem is concerned. How AI can contribute in using this? I don't discuss it very support this, but
you're talking about the spectrum and energy of the signal. Now, your question will be applied to millimeter wave. Millimeter wave is up higher spectrum. It uses up to 25 gigahertz, okay, which is so much. Now we are using on 3G only 3.5 and 3.6 gigahertz band. In millimeter wave, we are using 10 times more than that, all right? Which is affecting the health, obviously, because the energy of the signal is high, right? But is it everywhere? No. Is it close to the approximation of the body, of the human body? No. So choosing in the planning and design, we choose carefully, and this is, by the way, monitored and controlled by CITC, Hayat al-Ittisalat, right? And they are strict on that. They monitor it continuously to reduce the effect on the health. Sometimes AI can be on the drive test for on the field operation. One of the use cases, field operation. Field operation is a drive test. Either you as a device or advanced device, not a user device, or which we call it walk test. You walk with a device, you see the signal level. AI can give you an alarm without having to look at the device or make new measurements. You put it just on your pocket and it gives you an alert. This is being used now by CITC, by the way. And there are some dedicated companies that doing these systems, actually. One of them called Nemo. They have their own device and they have AI advancement software, which gives an automatic alert whenever there are risks, or OEM, which is electromagnetic radiation, okay, over. You're welcome. Two more questions and then we're done.
The relationship between the basic statements to human behavior.
6G.
Yeah.
Let's say 6G. I got your question. You're talking about the effect on the future, not now.
The benefit for it through this statement.
Well, exact answer, there is no. Even doctors and researchers, professors and scientists working on the medical field, on the electromagnetic field, they don't have exact answer. However, if we reach, now let me give you the spectrum. Where are we in the spectrum? We have from 0 up to the gamma ray. Gamma ray is nuclear. It's multi, I think microseconds or even nanosecond exposure. It's definitely. Yeah, the rate is not, which is 40, and then the microwave spectrum, which you use it in the database system, which is you are not always. They will all back the protein, protein. What do you mean? You have the new one that is coming from satellite, not a scenario. I have to look at the scenario.
Today I'll be talking about a topic that is at the very core of smart city development, which is trust, FILA. So we have technologies, we have everything, we have very good promise for very enhanced lifestyle. We have resiliency, we have efficiency, but trust is an issue, especially when we have a lot of technologies interconnected with each other. And these technologies are new, are recent developed technology. Dr. Abdullah mentioned about the Internet of Things, the IoT devices, whereby we need to move to the 6G, we need to consume more power, so more batteries. And if we consume more power, we cannot add additional processing to these devices. So if we want to secure it, we are killing the devices. So devices in the room or in any place in the smart city are there to listen, to capture information for you to take decision to enhance the life of people. But what would happen if these devices, these IoT devices, they passed away, the battery is gone, and you don't know where it is stored. So there is a very high risk that somebody will take it to his laboratory and figure out how it's structured, how it's designed, and he will try to mimic multiple devices that's not belonging to your own control. So it's a very risky environment if we don't bring trust, FILA to the smart city environment. So the focus of this talk will be around trust in the smart city environment. Exactly, everywhere. In the whole, in every corner of the smart city. Because smart city is a connected city, and its security, hackers will try to look at the weakest link in these connectivity. So if any of these connected devices is not trusted, we are. So before we explore the solutions to these, to the problem of trust, let me just look at identify security concerns. So we have three security concerns. One is security risk. This is where we are talking about unsecured IoT device. Unsecured means either by design it's not secure, or somebody was able to take it to his laboratory, manufacture his own IoT device, and try to fool everyone that this is part of your network. It's becoming unsecure, right? Like this backwards. So any unsecured device will create multiple points to the whole city. So we have to make sure that it is very secure. In 2021, in the US, a cyber attack was able to shut down a whole pipeline of fuel. And you can imagine what would happen if the same attack came to the smart city, the smart grid, in the smart city. This is number one. Number two is privacy concerns. The vast amount of data that is captured in a smart city, real-time location tracking, biometric information, digital identity. So imagine if someone was able to get a digital identity in the smart city, he is you. So if I took everything about you, I am you in my car. So when I open my car, it's my car. When I open your car and I took your identity, it's my car. And in the smart city, everything will be digitized, tokenized. It means everything will be using blockchain technology stored in the blockchain, so everybody will have any ownership of anything stored digitally on the blockchain. And how they can authenticate me using my digital identity, my biometric data, and so on and so forth. Privacy is an issue that we need to take care of in the smart city. Last but not least, the trust. So trust, when we have a centralized control system, we are depending on a single point of failure. So if this system is down, everything is gone. If someone was able to attack the system, it's a centralized system. One single point of failure, we are gone. So that's why using blockchain technology, we need to make sure that we distribute, we decentralize this task, so we have a different multiple dependencies, not on one single point of failure. So one of these solutions, one of these technological components is blockchain. And I assume we know what's blockchain, we know what's Bitcoin, we know all of these. It's a decentralized database. What we call is an tamper-proof. So any change we make to the record of blockchain, we can approve it was changed. So no one can change anything because we all have the same version of the proof. So if somebody will come and say, no, its name is this, everybody will be able to detect because it's decentralized. So we all have the same version of the truth. So we can detect for any tampering with the data. It's a transparent system because we all have access to the data, and at the same time, it's a decentralized control. So in the smart city, we look at what's called secure energy transactions. So let's say with this decentralized system, the households, my house and your house, we can exchange the surplus of my energy, electricity, I can trade it peer-to-peer, okay, without the need to go for a central system, because we can trade directly, peer-to-peer trading, even with the electricity surplus in my household. This is one way. Another way, the digital identity, as I mentioned, this needs to be properly detected without exposing sensitive data. So in the smart cities, I need to be able to authenticate myself without giving everything about me. So I need to prove you that I am the one whom I claim to be without giving you all the information about me. Last but not least, the trustworthy communication between autonomous cars, between vehicles, and the infrastructure. So this communication needs to be very, very secure, because if anything happens wrong, this will threaten the life of people you think about the traffic system, you think about your car that's driving based on the data taken from the AI system to take a decision where to go and what to do exactly. So by shifting from centralized system to distributed trust, blockchain enhance accountability, resiliency to the smart city operation. Zero knowledge proof. This is a topic that's recently came to the surface because of the blockchain. Zero knowledge proof is a cryptographic term. It's a technology in cryptography. It's a way that I need to prove to you something without giving any knowledge. So proving with zero knowledge communication. So I can prove to you that I know your password without saying the password loudly. So what shall I do? Give me a laptop and open your laptop. Change the password, give me the laptop and open the laptop. So every time I'm showing you that I know your password without telling anyone about the password. Zero knowledge proof came because of the need in the blockchain space, but now it's scaling up to other sectors. This is a very important technology that we need to use in the smart cities. Proof of residency without revealing the address of the individual. Secure access to buildings and transportation. So I need to make sure that when access to these is secure without disclosing personal details. And last but not least, the billing and notification system. I have to ensure to you that I'm paying my billing without showing you my bank account, without showing you any further details, and prove to anyone that I paid my billing, my fee. In the US, if your billing is above transaction above 1,000, you have to show the number for the taxation. But I can show the government that this transaction is below 1,000 without showing the exact number. So I can prove to them that these transactions are below 1,000 without even showing the number. This is a technology thanks to the cryptographic development and creation, because now we can do the knowledge through technology. Homomorphic encryption. This is another innovation in the cryptographic space. By the way, cryptography is not with security. So we use the complexity of solving mathematical problems to bring in security. So all of these terms, knowledge proof, even blockchain is around cryptography. And now we're talking about homomorphic encryption for security and computation. So you tell me how everybody is moving to the cloud, but for the medical sector to move to the cloud, we have very sensitive information, medical records, that we don't want to disclose to anyone. So how can I give access to companies to process maybe some research centers to process data from these records without saying that this record is for this guy and this guy, right? So I don't want to disclose information, but I want to give access to people to compute on these data. So what will happen now? These data will stay encrypted, but still people can get access to compute on these data. This is also very important in the case of smart city part, because in smart city, we need to make sure that healthcare analytics is done without disclosing records. We need to make sure that confidential anything financial transaction is there. So as I mentioned, when we exchange electricity, transact electricity, when we transact financial data, I won't have to give detail. So this transaction can be done and be verified and be validated without even showing any data, because these data are already encrypted. So it's processing of data while being encrypted, and there is no need to decrypt these data. Last but not least, homomorphic encryption enables secure AI-driven decision-making while maintaining data confidentiality. So data is still confidential, we're using AI, we're asking this data, and we can make the decisions based on these confidential data, based on what we need exactly without disclosing these data. Dr. Abdullah mentioned about the secure resource control device. We talk now about the sensors. Sensors could be traffic light systems, surveillance camera, these small sensors that you see everywhere. to capture information, right? Sensors are meant to capture information and to exchange this information with the decision-making system. So it can guide you, it can give you better life style, it can bring a lot of benefits. But what will happen if these resource constrained devices being attacked, right? And the best way to attack these resources is to hijack them, right? I know that the sensor is not over here. I will send a lot of transaction with the sensor. The sensor will pass away because the battery will be off. Nobody will be able to connect the sensor. I'll take it to my laboratory. With $100, I can figure out the secrets of the sensor. So I can copy as many sensors as I want. I throw it everywhere, it will collect information, it will see the decision making. Okay, so this is very important in the cryptographic aspect, in the context of smart cities, we need to bring in what's called lightweight cryptographic protocols. Lightweight means it will not consume energy, but it will bring in the same level of security. So now what people are thinking of, okay, let's change the cryptographic protocols to be less power hungry, less space hungry, less time hungry, but at the same time give equivalent level of security as many as the other cryptographic solutions. Quantum physics and quantum computing lead to the fact that we are still waiting for the quantum cryptography to come. When we have the quantum computing, everything will change, and all the aspects of cryptography will change. So all the research now, the industry are working on what's called post-quantum cryptography, whereby they have cryptographic technique that's immune, that's secure even in the presence of quantum computing. Quantum computing is a way whereby you don't have only two sides of the bar. You have multiple sides. So now your computer can run not only with 0 and 1, run with qubits. Like, like when you have a car that's moving in a stick wheel, it's like very slow, right? This is our current computer that we see it very fast. But when it's quantum, it's moving very fast because it has take every direction. So this will make sure, this will lead to the fact that any cryptographic system, because again, cryptography is based on the complexity of solving mathematical problems. So the current mathematical problem will take thousands of years to be solved. So it's secure, right? If the cryptographic system is secure by design, but when it comes to the cryptographic key breaking, it is very difficult because as per the mathematical calculations, it will take thousands of years. This is based on the current limitations of the current computing, that it's the 0 and 1. But when we move to the qubits, it's a different story. What's not breakable within thousands of years, not will be breakable in minutes. So this will make all the assumptions about very secure cryptography gone. That's why the world is moving to the what's called post-quantum cryptography. And this is very needed when we design and we want to bring trust to any smart city cryptography. So again, building trust, we need to implement trust security system in the smart city. It should be by design. So security should not come as a follow-up, as a second layer on top of the infrastructure. The security in the smart city should be by design. And this is the only way to move forward, and for the citizens, and for the investors, and for the government to invest in large-scale projects in the smart city. They have to trust it. They have to make sure this is a trustworthy environment. And it definitely we need to encourage collaboration. We need to encourage collaboration between governments, tech leaders, and academia to build secure framework for the smart city. Definitely the integration of blockchain, zero-knowledge proof, homomorphic encryption, and there are other technology coming on the way that need to be worked together. But this is not only a technological foundation; it's a foundation for the trust in the digital age. Now, the last slide, last but not least, just to make sure The goal of this speech is really to, that need to collaborate. Number one. So collaboration is not only engineers, it's not only economists, it's not only medical sector. It's all the sectors that will be operating the smart city need to collaborate from now. Because the need of the medical guy is not the same need of the of the telecom. So everybody needs to collaborate. So we have a proper design from day zero, so we can avoid any circumstances. So collaboration and innovation. Now, because of the AI, I think everybody in this room we have equal knowledge. If you don't have the knowledge, even 2 minutes, you will have the same knowledge. So now we have an equal opportunity. So there's no competition in terms of knowledge. The competition is in the innovation. And when we come to design any secure that need to trust in the smart city, we need to collaborate and to innovate. And last but not least, other than collaboration and innovation, let me see what I wrote here. So we need to make sure that the city is not only connected, but this is the main point. So definitely, Dr. mentioned very good points about these resource constrained devices that are looking for energy. But the issue when these resources will die, we'll have an issue. AI is very important. It helps us take decisions, but we need to feed the AI with the appropriate and right and validated and authentic security. Right? Blockchain is very important, but if it was not designed properly, we know that the blockchain becomes about consensus, it's about agreeing among the majority. But people will mislead this agreement, will be falling in the wrong direction. The proof is important, we want students to consider if you care about mathematics or cybersecurity. It's something that's going out of the blockchain space to, for example, the cameras. Cameras are cameras. When you take photo, it takes a signature, right? When you want to grab the photo, in the application, the signature will come. The signature is about the original photo. So how can we prove to the publication that this cropped photo is coming from this original photo? Geologically, I have to prove to them that this small photo is coming from the big one that was taken in Syria or in Turkey, for example. It was not taken in Russia. So these technologies are very important in the smart city. So when we say smart, it should be smart. It should be connected, it should be good lifestyle, but we should trust it. And I think technology is the best tool that students should look at its development, how to make it perfect. Thank you very much. I think we can have a few minutes for a question. Thank you very much for that question. For the trust, there are levels of trust, right? So the more trust you get, you need more, right? So trust definition is, trust is trust, right? But in this aspect, in the smart city context, there needs to be a collaboration to make sure that what's the KPI of trust? When you see people are accepting to use these digital services in the smart city, when you accept that you will not drive your car, but this photo drive will do it, right? So when you are confident enough that you go to the smart city, close your eyes, read your on your tablet, and the car is taking care of you, right? It's dropping you wherever you want to go. When you call program your your house, and your house will make everything for you. You have visitors, all the kitchen, everything is done properly. So when you are very much confident that these services are meant for you, this is the how to reach this level. We have to sit all together. Right? All the service provided in the smart city should be there. Okay, the KPIs, because I'm is the objective of the smart city. So people have to make sure that when they see someone doing this, he's happy, he's not having any issue with this, you know. So I think to make sure that have proper benefits. And this that will be a dashboard for everyone to see what's going on in this thing. Because trust requires transparency, blockchain is there to do it. AI will give you proper analytics, blockchain AI is there. You have a proper return of the dates in the place, so you are sure whatever is coming to your place is there. Definitely, there should be some sort of standardization, which I do not cover in this presentation or part. Any kind of device that's reaching, that's coming to your smart city should be standardized. So we cannot accept any device that's reaching your place that's not being verified, tracked in the okay. So we have all the tools to govern to make sure that standardization is there. And currently, what I will be in those any standardization powers. Okay. Based on that. Now, how to do smart city the same, right? Now, Google is not the smartest knowledge base technology I have seen so far, right? Because with Google Drive, with Google Map, we can do a lot. I can save more time, I can save money. It's a one component of a smart city. But infrastructure is not there. So you need to make sure that wherever you live in a smart city, that's something that's capturing data. You have to that whatever you do for them, that is something behind everything. Something that is big. You cannot see them. It's knowledge-based city. That's fair. Google Map is one of the knowledge-based knowledge economy tool. So the more tools you have, take a decision that save your time, the data efficiency, the availability, all safety, right? All of these now you can tell that we have smart and trusted. So again, I don't tell you, right? It should be so it should be smart and trusted. How will I answer this? What question? What question?
You said that take the car, but sorry, you only has your name there, has your name face, but the factor doesn't look like you.
Yes. Now you know the very much the question. Now you apply, now everything about you is currently stored somewhere else, right? On the your facial information, signature is there. Fingerprint, thanks to the technology, always offer you to give you better services, but they need to get information about you. So your fingerprint, your voice recognition, your face, right? So all of these are your passwords, right? Now you have an application that will give you hints how to get the password, and then an AI behind the wall that's doing many things to profile you and see what will be your next password. So we are in a very currently we are in a very bad situation in terms of privacy and security. Currently, that's what you see happening. So when your car is connected to your digital identity, so the car will not recognize you as you, right? As a person. It will recognize your fingerprint or your facial recognition or your password. All of these data, we don't have control over the data. So someone else can take it and can give instruction to the car. What's your name, please? Mad. So anyone can take all of these data, make the combination, and inform the car, and prove to the car that he is valid. Right? So definitely, Well, a smart city is built on the digital services whereby we are a digital signature in the database, right? So I am represented by a composition of different digital signatures, face recognition, voice, fingerprint, password, behavior. Now we are talking about something that is not in the presentation called attribute identity. What does this mean? It's coming out of my fingerprint, facial recognition, my voice. I have to do that I was on this place and this place and this place. So many IoT devices should validate. إذا جاء خاصة بلغة تتبين. What is the these sensors will say that he's the guy. So now your car, when I would a person can say, I'm valid. Let's say, okay, let me validate this with sensors that between your house or your work or your parking and here. This they see you because maybe somebody is coming from a different place. Right? So with smart city, that's why by design, it should be secure by design. So we don't depend on what's happening today. What's happening today is you. So attribute identity, authentication by attribute means I have to cross-check it by with different sources to make sure to create consensus that the one who's contacting out the car will open the car because you have to the car from the you will send the car to come to you. So this communication need to be secure and need to be authenticated. The authentication aspect need to be cross-checked, validated, consensus. Blockchain will play a major role in this through different IoT devices that they witness. They show you in this place at this time, right? So this the AI will make an analysis and will say not about 99%. The AI is not regular that much as managed not here. So this is one thing. Blockchain as per the current application of blockchain are very simply that one is the consensus because in blockchain it's decentralized blockchain it is decentralized, right? But it's a fully decentralized. It means there is no control, only by consensus. So let's say you have a blockchain at university whereby we have voting, right? So the voting would say that everybody will put his voting will make his voting, right? So this voting need to be done in a very decentralized way. And I would say number one that I can impersonate you, right? But I can vote twice. So blockchain will not allow me to do this level voting. Second one, the consensus. When we break a consensus, if the majority would say that this is not married, it will the blockchain will accept. Now, how to control this majority will not be misleading the decision, right? So one of the major issues now with the blockchain is the consensus by design is not secure. So now you see companies working on this. Another issue is scalability. Because in blockchain, we have three things. We have security, we have scalability, security, scalability, and the third one I forgot. But usually what will happen, companies will do two and miss the third. Right? Scalability whereby it's okay, acceptable for the small scale, but when you want to scale it up, it will fail. So the security issue on blockchain currently the major focus is in what's called consensus. That's why you see people moving to the same knowledge pool or more version and other sort of innovative cryptography to cover this issue.
I know that smart city council is very common. The process of all of this, like availability, offering services with cost-effective manner, and why we do surveys, continuous real-time monitoring and surveys to identify them. But there is a little concern. I know we've talked about cybersecurity and policies about the slides and blockchain, but does this raise a concern about that smart city makes more vulnerable to being hacked? It's easier to have iCloud system and with all the information out, especially if you are more living in a region where
Yes.
some people say.
Yes, yes. You know, the smart city is very beautiful, but very risky. If it's not by design, when I say by design, before you know, because usually in the traditional technology, when one design a system, we bring the only technology people. The hospital will bring the doctors and the medical team afterward, right? Just to check if they have a requirement. But in the infrastructure, it's only the technology, the engineers. In the smart city, you bring everyone. Because everyone will have a concern, as you mentioned, because if I don't trust, I will not be involved in it. I will not use it. So the smart city, let me give you an example, a simple example. Right? Now, when you want, your car will see a signal that's saying the speed limit is 80. I give this is the second time to come to the university, so I feel home. I give this example before. So when you're driving your car, you see a signal of 80. You know, you can tell. You can do the speed limit accordingly. But if this car, you're not driving it properly, it's auto drive, right? So the camera in the car will see the speed limit. So it will slow down or will increase the speed. Your camera. But your camera learned this from AI. And the learning repository data, so the education system of the AI with this on the cloud. So what will happen if someone will go and poison this data? Will poison. You know what's poisoning? He will put very, very little changes in the data because the AI data is spherical, right? So even these changes are not detectable, are not easily detectable. Currently, and poison to the AI data are not easily detectable. So you can see a water, you see this water is clean, but we don't know what's inside this water, right? The same way that you cannot see it by eyes. Technically, so far, it's not possible to detect these poisoning in the AI data knowledge, right? So the hacker there will poison the data. Your car will not be able to differentiate between stop signal and 80 speed limit. What will happen? You know, so definitely it's risky. But if we know this from day zero, we can tell. We can say, wait a second. Okay, let's make sure that these data are protected. So AI, how to protect it using cryptography? One, because in cryptography, I can go and do what's called hashing. You know, hashing is like you put something in a machine that will give you very fixed length text or string. If any change, any single change in this data, even if you change from a small letter to a capital letter, if you put a space, the whole thing will change. So if I put fingerprints of these data, I know the story. How to connect to the database to learn. It will not check the learning with these hashes. The same, it will say, Alhamdulillah, tawakkal ala Allah. Not the same, it will say, all the second, there's nothing. So there are things to be done to make sure that it's not easy. Technically speaking, that is there. There are some things are still under development. For example, technology group still under development. There are good problems there. Quantum computing possible still is there under development. Because why we are still in the post-quantum cryptography? Because we did not see yet quantum computing. So we are assuming that quantum computing theoretically will be able to do this. So, technically speaking, we have all of them, all what we need to have. But we need to define that we need to collaborate and do it. And let me give a certain example. Blockchain or Bitcoin, it was considered the best innovation, since years. Right? Bitcoin was created without invention. Nothing was invented. In Bitcoin, nothing was. There is no development. It was only innovation. What is the innovation aspect? People, they sit together on the same table, on the round table, everything coming from different industries. scientists, mathematicians, the government community, right? And to solve two problems. Double spending in the digital world, because if the money is acquired in my stream, I can send it to you $100, I keep the same, right? I can use it again. So double spending was stopped, and fully decentralized system was impossible. Because how come can I send you an email from me to you without passing by a central authority, right? It was impossible. But when everybody sit together at the same table, and what they did, they wrote what's available. So they wrote what they have. Mention. They did not create anything new. They just put what they have, put it at the table, but they mix it together. Right? And like actually, when you mix things together, you have two things, right? So they mix things together and they got the solution to a problem that was so impossible to be solved. Unsolved, right? So I think it's the same way we need to do in terms of securing smart city. We need to sit together, we need to collaborate, and definitely we need to innovate. Because we don't want any more to that. Invention might come as a consequence of our collaboration. So I think we spend a lot of time on innovation, on invention, sorry. But I think invention might be very time consuming. Things are moving very fast, so let's prioritize collaboration, innovation, and invention might come later as a consequence to smart city.
How do you do the communication? Right? One big example, what's up, why it's not enabled, so they're completely closed and goes to simply because they are not complying with the kingdom. So the CSP, they don't have a server yet in Saudi Arabia. Yesterday it was announced the cloud services data center, major data center regionally. By two companies, Microsoft and Amazon, to be installed together in collaboration with STC and Sonaya. This is just for preparation of the smart cities, mainly for the service related to monitor the Sonaya, CSP, and SASO, three different government entities. They are dedicated on standards in the devices, hardware and devices. So this is how we do it. And any contract is monitored by all the CST on certain checklist quality and security marks. So this is a very good initiative by the government, and they expect that to minimize the risks.
Yes. Thank you, brother. This is very good information because definitely we need to move in this direction. There should be standardization, there should be a kind of proper governance, otherwise, the just I don't want to discussion because in the current infrastructure, in the current IT infrastructure, security is weak. It's not very strong, this is global. Moving to the smart city, the risk is much higher. The more you depend on technology, the more we are threatened, we are vulnerable to multiple attacks. These attacks, some of the attacks are known attacks, and we have unknown attacks, and this is a risky spot. Exactly, none of that, but we have attacks that we never experienced before, because we have a new infrastructure that we never experienced before. So you build something, attackers will be smarter to do something more. So, and AI can help a lot figuring out the profiling and being ready for these unknown attacks to make sure that we have a proper countermeasures.
دكتور هلال ما كان موجود معنا في حتى الافتتاح. طيب شكرا لكم جميعا.
كاميرا